Okay, we're over at the bench and we have laid out in front of us all the parts that we're going to need to start the top end rebuild on our BSA Bantam. So we've got our cylinder barrel with its fresh rebore, that's the job that I outsourced, and our previously repaired cooling fins, that's in the previous video. If you haven't seen that, we did some welding. And we have our new piston, plus 40 piston, and that's been cleaned up. Just a bit of solvent really, just to get rid of the packing grease, any dust or debris that may be clinging to it. And the same with the gudgeon pin, cleaned up with a bit of solvent, get the packing grease off, ready to go. We have our piston rings. We'll be looking at those shortly. Just keep those in the original packing. And very importantly, our new circlips. Now, if you buy a new piston, you generally tend to get new circlips. But if you're fitting a previously used piston, don't skimp on the circlips. For what they cost, they're a very good insurance policy. And you know, the old ones may look serviceable, but chances are they've been weakened. And if you get one dislodged whilst the engine is running, yeah, it will really ruin your day. If you've got a nice new rebore job like I have, yeah, it's going to make a mess of it. And if you haven't rebored your cylinder, chances are you soon will be, because yeah, these things can write off a cylinder barrel and a piston quite easily. So, as I say, good insurance policy, changing the circlips. We've also got a set of feeler gauges. We're going to be using those on a couple of checks. Now, these ones are graduated in metric and imperial, and we're going to be reading the imperial graduations. So we'll have a look at those in a minute. And also, we've got some approved data in the form of our BSA service sheets. And there's a couple of service sheets that we will be referring to for a couple of checks that we need to do before we reassemble the top end onto the engine. So let me just get set up to do that, and we'll get straight into those checks. Right, okay, so the first check that we're going to do is the piston skirt clearance, and we do this from the spigot end of the barrel, which is why I've flipped the barrel over, and we are going to be using some data, which, if you are interested, is in BSA service sheet 704, piston clearances, all models. And it tells you that the following are the recommended total clearances between the bottom of the piston and the cylinder wall. And we're looking at D7, so third line down we have D5 and D7. If we follow that across, we're looking for between 3 and 5 thousandths of an inch. So let's get that out of the way. Let's have a look at our feeler gauges. So between 3 and 5 thousandths, well, in that range, just outside of that range, I've got a 6, I've got a 4, I've got a 3, I've got a 2, and I've got a 1.5. Hopefully we don't have to get down that small, because we're out of limits if we do. Similarly, if we can get a 6 thousandths in there, again we're sunk basically, aren't we? Because we're out of limits. So I want to make sure that you can see this. So I will try to keep my hands out of the way, but not going to be the easiest task, I don't think, but I'll try. So let's try with a 6 thousandth, and I will try and get that in. And I'm just making sure that the piston is hard up against the cylinder wall. No, that is not going in. So we will try the 4 thousandth. Haven't got a 5, unfortunately. But that is going in. Let's just get a bit more piston engagement now that we're in. I don't know if you can see that very well, but the feeler gauge is in there. I am having to put my hand in the way, unfortunately, but I would describe that as a good fit. So that's at 4 thousandths. I'm going to go with the 3 just to be complete. Yeah. yeah, the 3 is what I would describe as a slack fit. So I'm going to take that as 4/1000ths, which is good. Excuse me, kick the camera. Yeah, very good. 3 5/1000ths is the tolerance, and we're at 4, so we're right in the middle, which is good. I'm very happy with that. So the next job we're going to do is the piston ring gaps. So let me get to the right page in the book, and we'll have a look at that. Piston ring gaps then. What is the big deal about these piston ring gaps? Well, there is a piston ring, and there is its gap, and as you can see, it's quite large. If it will focus, there we go. Now that gap gets considerably smaller when we insert it into our cylinder barrel wrapped around our piston, and if it's too small, then as our engine goes up to operating temperature, there's the danger that these two opposing edges can contact each other, and then obviously that creates a mechanical lock and prevents our piston ring from expanding any further, and we'll get a seizure in our bore, and we don't want that. Counterproductive. So manufacturers specify minimum ring gaps, and if you find that it's too tight, you can very carefully take a file to your piston ring edges and increase the gap. Now on a 2-stroke we have that little L shape, so we want to avoid taking too much off, otherwise we'll lose that. And what that is designed to do is to locate onto a peg on the piston. Let me try and show you that. There we go, we've got 2 pegs there, you can see them in the ring grooves, and we should have another one on the other side of the piston in the middle groove. There we go, there it is. And those little pegs stop our piston rings from rotating, which they, in a 4-stroke engine, the piston rings sometimes rotate around the piston. They just find, their natural position. We don't want that in a 2-stroke because we have ports let into our cylinder wall, and if the ends of the piston rings find a port, then they have a tendency to want to disappear into the port, and as the piston ascends or descends, bang, they get broken off. So suboptimal, as I'm sure you will agree. We don't want piston rings breaking off in our cylinder, because we get disastrous results. So let's measure our piston ring gaps, and the manufacturer gives us his tolerances, and on this occasion we're looking at BSA service sheet 504, and about 2/3 down the page it tells us that they should be not less than 0.08 of an inch or 0.2 of a millimetre, and that is what we're going to measure. And we'll do that by inserting the piston rings into the bore one at a time, squaring them up with the piston slightly, so that we ensure that we get a good measurement. If they're skewed, you could end up with the ends of the rings like this, and that would give us a inaccurate measurement. So we'll use our piston, and we'll just go down to the first ring gap all the way around, and then we should have a good chance of being square. So we'll start off with our 1/8 thou feeler gauge, which is the minimum that we want. If this won't go in, then we've got problems. I'm going to try and do it so that you can see what I'm doing. Okay, 1/8 thou goes in easily, so already we're on to a winner. But I am interested in in what the gap is, just for my own sort of sake really. So let's try a 10th thou, see if that goes. That goes relatively easily as well. We've got a 12th thou. Is that going in? I don't think it is. Oh, yes it is. That's more like it. That's quite a tight fit actually. So we're probably between 11 and a half thou, I would think, judging by that fit. So there we go, that's our first one checked. I shall do the other two exactly the same way, off the camera, because you've seen it now. It would just be repetition for you. So let me get those done and then we'll come back and I'll let you know what the results are. Okay, that's all three piston rings checked. So our first one came in at about 11 and a half thou. The second one was exactly the same as the first, about 11 and a half thou. And then the third one felt just a little bit slacker, probably nearer 12 thou. So they're all within our tolerance, which was minimum of 8 thou. BSA didn't give us an upper region, but you know, we didn't want them to be enormous. But very happy with that. So no filing required, and we can get on with the top end rebuild. If you watched my last video, we were talking about materials a little bit. We were talking about cast irons, and these piston rings are cast iron. And you may recall me talking about modified cast irons, and these will almost certainly belong to that family. My best guess would be meonited iron, nice evenly distributed carbon, good wear characteristics, good heat distribution characteristics, all the things you want in a piston ring, and still very easy to manufacture, easy to cast. So that would be my best guess. We've digressed a little bit there, but you know me, I can never resist talking about materials. So yeah, that's what I reckon. My best guess, but anyway, it makes no difference, does it? We've got our piston rings, they're the right gaps, so let's crack on and put the top end back together. Right, okay, we're going to have a go at fitting our piston rings, and everything's had a clean. Another clean. Can't emphasize really enough how clean things need to be, and you don't want to be dropping any dirt down inside your ring grooves. So we've got our piston rings, and we've got to get 3 rings past the positions on our piston and into the respective grooves. Now we could go from the bottom all the way up there for the lower ring. I normally go from the top, but you could do that. The thing you've got to be careful is that you don't drag the ring up the skirt of the piston, put a nasty score in it, because that would be a bit tragic really. What I do is I use slips, which are just thin pieces of metal. These are actually long series feeler gauges that were actually cut down for shim stock, and I just use these as a little guide really. They just sort of they help your piston to they help your ring rather to slip down over the piston, over the ring positions. There's no real sort of magic to it or skill to it. You've just got to persevere with it really. And if you get a ring like the edge of the ring there stuck in a groove and you want it to go past there, just work your slip around, and then it said shim. Work your slip around until you free it, and then just move it down a little bit. So we want our gap here, because that's where our bottom ring peg is. So we're just going to work our piston ring round to that position on our slips. And straight off the bat, not practicing what I preach, and our ring has popped into a groove. So there we go. It's moving down. We've got a little bit of a problem here. Oh, you can't see, sorry. There we go. Okay, so we're just about there now. The good thing is we're not scratching anything. We're not overstressing the piston ring, because these things are, you know, fractions of a millimetre or thousandths of an inch. And then when you're roughly in position, pop your slips out. There we go. Piston ring in position. As I say, you could do it from the bottom if you wanted to for the lower ring, as long as you make sure that you don't drag the open ends of your piston ring across the skirt, because you know, you're going to score up your nice new piston, and that's not ideal. But I like to go the shortest route possible, so I go from the top. So we just got to repeat that process now a couple more times. I hope that that was clear to you. I'll do the other two off camera, and then we will we'll have our assembled piston. So I will see you in a minute. Okay, so 3 rings fitted, and just make sure that there's no binding. There we go. There's our. You see it going up against a little peg there, maybe. Can you see that? So that's the piston ring locating against the peg, or rather locating towards the peg, and you just check that they're all free to move in their grooves, and you shouldn't have any problems. Where's the peg for this one? There we go. So, all good. And as long as when you fit the piston into the barrel, you make sure that the gaps are at the pegs, and that the rings aren't over the pegs, because, oops, helps if you can see, that's how you get broken rings. If the peg slips over if the ring slips over the peg rather, you can get broken rings as the ring fails to compress as it enters the barrel. But as long as we're careful with that, we should not have a problem. So we'll move on to fitting our piston to the connecting rod and moving forward. All right, what's he up to? We've got bits of wood on top of the engine. We've got a strange looking bolt going through the little end. Something strange is going on here. Well, I've decided that now's the time to fit my ignition rotor, because I've got to torque it up to about 50 foot-pounds, and now on my old Simpson and MZ engines that I used to tune, I just use a strap wrench. I don't think we tightened them up that tight, I can't remember, but just use a strap wrench, and I think at 50 foot-pounds it'll probably slip. So I'm just going to lock the crank up by using a rod through a small end, and I've got the gudgeon pin in there so we don't damage the needle rollers, and then I've got this stainless bolt which is actually out of a gas turbine engine, but I'm sure it'll be man enough for the job. 2 bits of wood, one either side, just so that we don't mar up the top of the engine casting, and we're going to use that. We'll lock the bottom end, get the rotor on. Once that's done, we can crack on and do the top end. So I'll get that done, and then I'll bring you back. Right, well, that's the ignition rotor fitted, and I'm not trying to get one past you. It is a new ignition rotor. I do have a new ignition system for this bike, which I'm pretty excited about. I'll share that with you in another video. I think it's going to give this bike a new lease of life, I really do. So yeah, exciting stuff. And as you can see, there's the original rotor that I removed. Quite a considerable difference in size and in mass as well. So yeah, I'm happy about that. There's just one check I need to do, which is why I've got the housing here fitted, the cover. I just need to check the clearance between the end of the rotor and the cover, because that will give us the clearance for the stator. And you recall I rebuilt, excuse me, I rebuilt the crankshaft, and this is just really checking that we've got everything in the right place. We've got the end float right, and which we know we have because we checked it, but for this ignition system, you need to have the right clearance. So we're just going to check. We're looking for no more than 4mm, and I'm just going to do it with these two steel rules. Let's have a look. And we've got a shade over 3, so yeah, we're in the right place there. So I'll take the cover off, and we'll get back on with the top end rebuild. Okay, well, it's time to fit our piston, and we're just noting the orientation. The service sheets tell us which way around the piston goes. We've got our 40 thou mark on the crown, which faces towards the exhaust anyway, but if we're in any doubt, the service sheet tells us that on a D7, the piston ring grooves, the piston ring gaps rather, face the front. If it was a D1 or a D3, I believe, I can't quite remember, the piston ring gaps would be at the rear, but they're at the front. It's a D7, and you see in there I've already fitted one of the circlips on the opposite side to where we'll be working. And then we'll push the gudgeon pin through and fit the final circlip. So that's in there nice and securely. I've given it a good poke and prod to make sure that it's in the groove, and the closed end is towards the top, which is the way I was taught to fit them, and we should be good to go. So we're just going to put a little bit of oil into the gudgeon pin bores and on the pin itself. And then we'll put some oil on the connecting rod, small end bearing, and we'll fit our piston. Okay, I'll try not to get in the way, but I think it's inevitable that at some point I'm going to be blocking the shot. You'll note that I've packed out the crankcase mouth with a plastic bag. You can use rags or you know, strong tissue, you know, the sort of workshop wipes, that kind of thing. Although you've got to be careful because these things like to leave bits lying around if you aren't careful. But whatever method you use, it's up to you. But do pack out the crankcase mouth, because if you drop something down there, if the circlip goes down there, yeah, it can ruin your day. But let's get our piston into place. There we go. Just get something to push that pin through with. Pays to be prepared, which I wasn't. There we go, that's all the way through. And we've just got to put our final circlip in. So you can watch me do that, hopefully not fire it across the workshop. Because now the camera's running, obviously things are 10 times as difficult, or maybe I'm just making excuses. Okay, in you go. I haven't heard it click yet. There we go. Just double check. Excuse my head getting in the way. Not entirely satisfied that that's fully home. So I'm just going to give it a bit more of a poke and a prod. There, I think that's got it. So that is our piston fitted to our connecting rod, and looking pretty good. Ready for a barrel, I think. Oh, right guys, unfortunately that's going to be it for this video. Like an absolute Charlie, I was greasing up the base gasket prior to fitting it, and yeah, I managed to tear it. So that's the end of that job, unfortunately. I haven't got a spare gasket, and my gasket paper could be in here somewhere. I'm not quite sure. So I'll have to either dig the gasket paper out and make one, or get one ordered. But very shortly there'll be a part 2. We'll get that barrel fitted, and we'll probably go through the ignition system as well on that video. Make it, you know, a fairly interesting, hopefully fairly interesting watch. So apologies, I can't go any further at the moment. During this video, I have been saying things like that's how I was taught, and you know, that's how I was shown to do it. And of course, I'm referring to my granddad, who taught me so much about engineering and mechanics, things like that, as well as, you know, many other lessons in life. And he actually gave me all of the original data that I work from. These BSA service sheets were his, and I've got some more 4-stroke ones, and I've got some Triumph stuff as well. And you know, they were all the ones that he used when he was working on his bikes. And he gave me these when I was about 10 years old, and I've had them ever since. I'm almost 50 years old now, so you know, I've had them quite a long time. And yeah, it's great to be using them to work on my own bike. I kind of always knew in my mind that I would one day, and it just feels great that those days are here. And my brother and I have been talking about him quite a lot recently. My brother came to visit me recently, and we dug out the old photographs and went through them, and yeah, we were remembering everything that he did for us as we were growing up, and it was you know, fantastic times, really. We wouldn't have got by without our grandparents. They've actually brought us up, really. So good days to remember. So if you've got somebody like that in your life, if you've got a mentor or a relative like that that's you know, means that much to you, cherish it, because you know, it's more precious than gold, and it's the most important thing there is, really. So yeah, take care of them, and let them know that that you care about them. So that's where we'll leave it. Thanks for watching. Thanks to all my subscribers. If you're watching and you're not subscribed, please do subscribe, or consider subscribing. It'll help me to grow the channel and put out more videos. And as I say, we'll be doing a part 2 very soon, so watch out for that, and I hope you enjoy it. Bye for now.